I was thinking. It's thinking. All right. Here we go. Okay, thank you everyone for joining us today for the August 2026 meeting of the Freight Advisory Committee. As always, we'll start by doing introductions. We'll go around here in the room and then I'll read off the folks online. So I'm Ethan Townsend with the Capital Region Transportation Council. I coordinate these Freight Advisory Committee meetings as most of you know.
Valerie Dean, New York State DOT Region 1.
Ed Thompson, DOT retired, Valerie's predecessor by a couple of steps.
Lou Esposito, Bridgetown.
John Scavo, Town of Clifton Park Planning.
Adam McCarville, Capital Region Transportation Council.
I'm Connor McDonald, Capital Region Transportation.
Connor has just joined our staff, so you'll all be seeing more of him through these sort of meetings. Online, we have Andrew Tracy, also with the Capital Region Transportation Council, William Fitzgerald with NISDOT, Dr. Catherine Lawson with University of Albany, Ryan Riper with the Town of Wilton, David Sawitz, Director of Transportation at Market 32 and Price Chopper, and Kim Lambert from Saratoga County. So just as always, we'll really quick review our hybrid meeting guidelines for folks online. Please mute your microphone unless you have something to say, in which case you can unmute to say it, or you can use the raise hand feature. You can also leave a message in the chat and I will read those off once there's a break in the conversation. And as always, this meeting is being streamed to the Transportation Council's YouTube page where people can go back and watch it later if they miss anything. So we'll go through the agenda real quick. We have a bit of an atypical meeting this week where we're going to start with our typical discussion item updates. Then we'll get our updates from around the table and talk about our upcoming meetings. Then we'll end the meeting with a featured documentary screening. We'll be watching the documentary Container Ship XXL, which is about some of these largest container ships that we have in service internationally. It's a very timely topic given, the supply chain issues we've seen through COVID and with the war in Iran. Just seeing how so much of our goods are moved through these container ships. It should be a very interesting watch. So if folks have to hop off at that point, totally understand, but that'll be the last part of the meeting. So we'll just jump right into the discussion items. First, we just want to give everyone a quick update on the Superload Corridors update that we have ongoing. Some of you were participants in our first study advisory committee meeting, which was held on June 10th, where it was really a kickoff meeting for the study. We reviewed the study purpose, we reviewed our stakeholder and public outreach plan, as well as the data collection plan that were being developed. Those data collection and stakeholder public outreach plans have been completed at this point. So we have our stakeholder interviews ongoing. Our project team has met with dozens of individuals and organizations to get their input on from manufacturers about the stuff they're producing, from local municipalities about their experience with these moving through, from the haulers to the ports to railroads. We're trying to meet with everyone just so we can get as much feedback for this study as possible. And so through that process, we have identified a couple of design vehicle sizes. So those are in a table up on the screen. So our first design vehicle is something that just meets the superload threshold for one of the dimensions, but has a significantly higher weight. So if anyone doesn't remember, a superload is any vehicle that's 16 feet or taller, 16 feet or wider, 200 feet or longer, or 200,000 pounds or heavier. So that first design vehicle meets those dimensional thresholds pretty exactly. A big reason for that is that the majority of the superloads we see in our region are superloads because of the weight. We do have some that exceed those dimensional boundaries, but the weight is oftentimes the larger constraint. So by increasing that weight, we're hoping to find a route that will serve most of our goods. We then have a design vehicle number 2, which is taller, wider, and longer, and also heavier. That encompasses, I think, every superload we've seen in this region that we have data for meets those size thresholds. And that's going to be harder to route through the region because the height is probably the most constrained dimensional feature for a vehicle moving on the road, because it's hard to interact with that overhead infrastructure, particularly bridges, make it very difficult. We have a very bridge heavy region, as we always like to say when talking about, funding and resilience and infrastructure. Those same bridges also are a pretty significant constraint for superloads. So for those size vehicles, that's where we're starting to look more at the intermodal access. There will always be some things that need to go on the road, but if we could move some of that traffic from the road to rail to the canals, that would go a long way in alleviating some of those difficulties that they have trucking through the region. So those aren't finalized yet. We have a couple more stakeholder interviews to do, and that'll cement our design vehicles, which will then run through some screening tools that DOT has. We'll begin doing LiDAR scans throughout the region to identify, looking at the constrained points and seeing exactly what the dimensions are that are causing a problem. For those who aren't aware, LiDAR is basically a truck drives through and blasts thousands of laser beams at everything around it, and then collects the reflected light. So you get very precise measurements for everything that is scanned. So that'll be really helpful for identifying those specifically constrained sites. We also have a project website coming soon. We have a draft website of it up that we're just reviewing and finalizing. Once that's available, we'll share with everyone. We'll include in the meeting minutes for this. So does anyone have any questions about the current status of the superloads or anything they'd like to share that we haven't heard yet? I'll take everyone's silence as a sign we're doing good stakeholder outreach. We're hearing a lot from everyone, and really appreciate everyone's participation in this study. So next I'll turn it over to Adam for an update on Capital District Clean Communities Program.
Thanks, Ethan. So I'll keep this pretty brief. On June 25th of this year, we had our first stakeholder meeting, and it had just around 15 attendees. So that was a pretty great start given that it was the first official meeting we had since funding returned in April of this year. At that meeting, we had Jacob Beeman from National Grid speak about their fleet electrification programs and initiatives that they're able to assist municipalities and stakeholders with. It's mostly on the grid side, not necessarily the vehicle side. But they can do a lot of assistance and problem solving that could be useful for when you're going on about those projects. So definitely worth looking into if you're pursuing that type of transition. And then also a resource I wanted to share with this group specifically is that the Advanced Vehicle Technology Group has an electric vehicles essential online training in case there's any fleets that are looking to go after scaling up their workforce for hands-on technician style trainings for how to handle and maintain and work on EVs. It's a great resource if you're looking to do a training for those folks. And if you're interested, email me there's my email. There's a discount code involved that we can work with through Clean Cities. So that's helpful. And then just some upcoming events I wanted to note is that, so on August 24th, I'm having a fleet intelligence meeting, not open to the coalition, but just a meeting with the group Biotech. I'm going to be sharing those findings with Capital District Clean Communities. It'll be nice to know what new leading edge, I guess I don't like to use best practices, but best scenarios and strategies that fleets are considering across internationally as well. And then as well, September 1st through 3rd, I'll be attending an annual training that's run by the Department of Energy. This is to scale up staffing and better understanding of programmatic goals that are coming down from the top federal levels down into clean cities and communities as a partnership program. Part of what we have going on is with this, we have to follow and abide by the different the different structural requirements that the Department of Energy has upon Capital District Clean Communities. So it's to work on this program for our region while also matching the goals and initiatives of the federal government's top-down approach. Thank you.
Awesome. And I shared the link for that electric vehicle essentials training that Adam mentioned in the chat. It'll also be in the meeting minutes as well as Adam's email for anyone interested in that. Yeah, question 10.
Are you seeing any interest at all with the post office in electrification of local delivery vehicles?
Post office. So I mean, that would be a really interesting fleet to look into. But I haven't had any outreach from that space, but I mean, I like that idea though.
Yeah, I mean, because they have a defined circuit every day, and it's not long range, and go back at night and charge up. The other comment, currently I work part-time for Hertz Car Rental. And it's kind of interesting. We have a number of Teslas in the fleet, which are getting up to 130, 140, 150,000 miles. And the reason they're keeping them, there's no secondary market for it. Hertz turns over a lot of vehicles. Actually, they have their rental vehicles, and then when they get more or less high mileage, they become Uber and Lyft available. And we have electrics, and we have some very nice ones, Japanese and Korean electrics. But then we have the Teslas, and I keep seeing that they're repairing and updating these 130, 140,000 miles. So I asked, and they said, nobody wants them, so they're gonna run them into the ground. Just a comment on what's happening now.
I appreciate that. I mean, it's good insight because, I think that's one of the gaps is not being able to know what fleets are, well, fleet managers and people in that space are really seeing with vehicle usage, with actually end point usage of, what's going on. So,
Well, and then the other comment, given the attitude of our current administration toward alternative forms of energy, your Kansas City meeting could be quite interesting in terms of what's coming down now from the federal government. That could be interesting.
I mean, that is a great point because I think one of the nuances to this program, the program of Clean Cities and Communities is that it's supposed to be like a fuel agnostic program, meaning that their view right now is very much, well, what is your region's need case for alternative fuels? So if it just so happens that you're like, well, we're focusing on EV fleet electrification, well, then here's resources that can help with that. But they're looking to have it be, here's an umbrella of options. And, that's kind of the view that they're looking to have right now. But like you're saying, I'll see how that holds up.
And I just remember one further thing that, given the fact that Hertz devoted a fair amount to purchasing EVs, they do have high-speed Tesla chargers at the Hertz Airport facility, in addition to the regular slow chargers. They have quite a bit of charging capacity at the main Hertz facility at the airport. I work at the Schenectady neighborhood, but we go back and forth to the airport all the time.
That is good to know, though. Thank you.
Yeah, the Tesla high-speed one. So in other words, I'm guessing, and I don't know that much about it. You've got a Tesla that maybe shows up like 20% remaining. You can go up to the airport, plug it in, and you can get it to probably about 80 within about an hour and a half. That's rough. I'm not very good on those, but that's roughly.
Yeah.
And one thing about a Tesla, and we are in a number of different kinds of vehicles every day. And one thing about a Tesla is, I don't know whether you've heard of one pedal driving,
Yeah.
because as soon as you let off on a Tesla, boom, it slows you right down. And when you're in 6 and 7 different kinds of vehicles every day, you better be careful making your transition.
Appreciate the share.
Thanks, Ted. Thanks, Adam. We'll look forward to hearing about that
Yeah,
Kansas City training in November at our meeting.
Yeah, make sure to share those takeaways.
Awesome. All right, next thing is an update on the Clemens truck reroute study, which some of you may have heard about. Is a study that the Albany County is taking on to look at truck routing from the port of Clemens to the quarry right there on the other side of the village of Ravenna. The village is let's say has not been happy with the amount of truck traffic heading down their main street, which is you know, it's a fairly tight road, very residential area. And as we're seeing increasingly across the country, across the state, even in our region, is frustration that communities are having with truck traffic. And there's a variety of reasons for that, and that's a separate conversation. But for this study in particular, they're looking for alternative ways to get from the Port of Clemens to the quarry. And they just recently had a public meeting where they shared some alternatives to get public feedback. They showed 4 alternatives, one being the existing route, basically a no change option, and then 3 potential new routes. And so we'll go through those real quick. If anyone wants to check out this study later, there is a website that's up on the web page on the screen there for ClemenstruckStudy.com. I'll drop that link in the chat in just a little bit. But so we're going to go through these alternatives in slightly out of order, in the order of essentially what the public has been sharing as their preferred alternatives. So the first one that people are the least interested in is the is alternative C, which is the existing route, which goes from the port through downtown Ravenna up to the quarry. This is the route that lots of trucks take each day. And as you can see, it's a little hard to see on the screen up there, but there's a lot of residential and commercial properties along that route who feel impacted by this truck traffic. But it is also a very direct route. It's very quick for the trucks to get between the quarry and the port. So then to get into the alternative routes, we have one. So these are 2 routes that use existing roadways. The first one on the left, alternative route A, goes up north along, I think that's 144. I can't quite read that. Crosses over 87. So that's one of the big constraints for this truck routing, is that you have to get over the thruway, which doesn't have that many crossings. So going up north, crossing the thruway, and then coming back down 9W down to the port. As you can see, it is a significantly longer path than the downtown route. It also still impacts quite a few properties. Both of these alternatives impact more commercial properties than residential properties, but they also impact more properties overall because the route is a lot longer. Some folks say, you know, it's less of an impact driving a truck past a property on 9W, which is a much larger road, than down Main Street in Ravenna. But that's just one thing you need to consider, is the number of properties impacted by these routes. Alternative D goes down south rather than north. Basically the same thing, just going down south to avoid Ravenna, crossing the thruway to get to 9W, and then going north to the quarry, or I guess going the other way, going down 9W to avoid Ravenna to go up to the quarry. Trucks go both ways on this route. So either way, these routes are either going north or going south significantly. Significantly longer routes. It takes it from just under 3 miles to just over 6 miles, which, for an individual trip isn't that bad. If you're doing that multiple times a day, it can get a lot. Obviously more distance traveled by these trucks means more impacts to our infrastructure. There's just more vehicle miles traveled through the region, more emissions, more fuel for the businesses to use. And so that's kind of why these concerns are what all led to what most of the community members find to be their preferred alternative, which is this route B, which is essentially to build a new road that stays on the property owned by the port and by the quarry. It would be, I believe, I'm having a hard time telling here if it would be a bridge going over the thruway or if they would go underneath the thruway. But essentially a new road that goes directly from the port to the quarry. This route is also not very long compared to those longer routes, which I think I might have got. This one says this one's 5 miles, so I might have gotten the distances wrong on those other ones, but a very direct route and also very minimal impacts. This route impacts the least number of properties overall. It also mostly impacts vacant properties, that are there in that sort of industrial area around the port and the quarry. You can see on that little chart on the left that you have, I think it's 13 vacant properties, and then you drop down to 6 residential properties, 4 commercial properties that are being impacted. This is also obviously the route that would require the most investment because you're building a new road. Those other routes are not, they're using existing infrastructure, and it would just be a message of signage and enforcement to get trucks to use those routes. This would involve building a new road. So I'm not sure if the study has progressed enough where they've identified the cost that would be associated with building this road, but like I said, this project's still in pretty early phases. They just had their first public meeting where they shared all these and collected feedback. I think are now refining the alternatives so they can come up with recommendations for the study. So we at the Transportation Council have not been too involved in this study. We've been kind of keeping tabs on it. We're hoping to be a little more involved once the concepts are a little more fully fleshed out. But if anyone's interested in this project, I'll share the link in the meeting chat. We'll also include it in the meeting minutes. You can reach out to Albany County Planning or DPW departments, as they're the ones who are actually doing this study with Creighton Manning as their consultant team. So
What was wrong with the other route?
the original route, I think that the county was just hearing lots of complaints from the residents about the number of trucks going through Main Street.
So for how many years has that quarry been there?
A lot.
And now all of a sudden it's a problem.
I think it's been a problem for quite a while. I think that I don't know the local politics there. I think there's just been kind of a resurgence. I think it kind of comes in waves where people feel particularly impacted. I'm not sure if there's been increased output from the quarry or increased activity at the port. But yeah, for whatever reason, the residents, it's become an increased issue for them, and they've made that heard to the county legislators.
Do you realize how much fuel trucks are gonna be using at 4 miles to a gallon hauling them loads?
Yeah, a lot.
And what the cost is gonna be to build a new road?
Yeah.
With a bridge?
It's
Because the residents are complaining about it?
Yep, yeah, this study, they applied for funding through the Transportation Council in our recent solicitation. This was not a study that we chose to fund at the time. There were a number of reasons for that, but it is something that the county has decided they want to pursue at least the study to identify what the options are. So, you know, there is an alternative up there that is just continue using the existing route, and that might be the final recommendation of the study. But if that were to be the final recommendation of the study, you know, then the county would at least have the backing to say, we looked at these alternatives. Here are the reasons why the existing route is the best route. So that is definitely a possible outcome of the study.
At 4 miles to a gallon, at the most, they're gonna be getting hauling them kind of loads.
Yeah.
You're talking 3 to 6 miles more.
Yeah, so like I said, the study is still early in its development. We'll share updates as we get them at our office. But if anyone is interested in providing feedback, you know, that would be good feedback for the county to hear. So I think the more input that the county gets on this study, the better. And
Is there any growth projections for increase? Has it been pretty consistent with the volume of truck traffic over the decades, or?
that I'm not sure about.
Okay.
That's good.
Yeah, this information is all was shared with me
Gotcha.
by the county. So they, I'm sure they have those numbers and are taking them into consideration, and they might be available if folks are interested. So I'll just drop that link in the chat real quick. And like I said, as we get updates, I'm sure there'll be updates on this study by our November meeting, and we'll share those with this group as well. So the last thing that we have is just our typical updates on our regional planning studies. You know, no big changes here from our May meeting. We have our Aiken Ave study and our Town of Stillwater study, which are both in the process of getting started. Both of those have, you know, they're out of the initial just scoping phases, and those should be developing soon. We also have our larger studies, our Albany County study that we're looking at some trails and sidewalks in different spots in the county. as well as a couple of other smaller tech assists that were getting started, and then our larger initiatives that are still ongoing, including that superload plan that we talked about. And then we have also just selected a consultant for our capital region resilience plan. I'm sure we all felt the impacts of the rain the last couple weeks. This was, I think I heard the most rain that the region has gotten since one of the last hurricanes to come through the area.
Yeah.
I know I experienced a number of road closures as I was traveling throughout the region, and many warnings saying do not travel unless you're escaping floods. So hopefully this study will identify improvements we can make throughout the region, both at specific sites and then system-wide, to help mitigate the impact of these increasingly frequent extreme rain events. So if anyone's interested in that, reach out to me. I can connect you with Andrew Tracy, who's our staff member who's leading that resilience plan. So unless anyone has any comments about those, now is our typical participant updates section of the meeting. I'll start with folks in the room. Does anyone have anything they wanna share about recent freight activities?
Yeah, I'd like to know what roads in New York State are designed to haul 700,000 pounds.
Yeah, not a lot.
I don't think there's any.
Yeah,
I know there's no bridges.
Yeah, that's part of the reason we're doing this study, is to identify specific corridors that we can invest funds in to strengthen that infrastructure. Because we do have loads that are that heavy and heavier that do move down our roads, and they're having a pretty significant impact. Yeah, I mean, you're aware, in the town of Princetown, that's where a lot of those GE loads go through, and the impacts on those roadways. We've been hearing from our other local cities that have underground utilities about their concerns about heavy loads rolling over those roads. And right now, the process is essentially find whatever route you can, and then go down it. And then the municipality is, you know, if there's degradation over time, it's not associated with an individual load that can then be mitigated by a particular manufacturer or hauler. So the goal of the study would be to identify routes that we could increase the we could use federal funds to harden that infrastructure to handle those extremely large loads, or get them more onto the rail and more onto the barges is another option. But those will also have their own constraints, of course. Yeah.
Oh, nothing here.
Thought you're raising your hand.
No, nothing here.
Anyone online have anything they want to share with the group? Feel free to chime up if you do. Going once, going twice. All right, well, that's all of our discussion items and updates for this meeting. We just have one more meeting remaining for this this year. It's going to be on November 18th. You know, is our tentative date. We'll confirm that as it gets closer. It looks like we are lined up to have a representative from the Canal Corporation come and speak to the group about the canal's current perspective on commercial traffic, what they're seeing in terms of capacity and usage, and their plans to, you know, we've heard that they are trying to increase the amount of commercial activity moving through the canal after a number of years of it, of that capacity being pretty limited. The state as a whole is trying to reinvest in, you know, this pretty significant and historic piece of commercial infrastructure that we do have and that is fairly underutilized. So that should be a very interesting meeting. Hopefully that presentation will end up happening. And as always, we'll send out that meeting agenda once the meeting date is a little closer. At that meeting, we'll hopefully have our tentative dates for 2027 to share with the group, which will probably be this same February, May, August, November schedule that this meeting has typically had. So that's all for that. So now we'll move on to this whole documentary screening that we have. Let me pull it up. So the documentary, like I shared, is called Container Ship XXL, and it's going to explore the production and the use of some of the largest container ships currently in service in the world, and just, you know, all of the work and the logistics that goes into building these ships that are then used to haul almost everything, that we purchase, and use in our day-to-day lives. Obviously, some things can't be moved through container ships, but almost everything can. And the larger these ships get, the more goods can be moved. But it also means that there's bigger impacts when something goes wrong with a ship or with a region of the world. So we'll get into this now. I'll dim the lights in this room a bit. We won't turn them off. And folks online, hopefully it'll all look and sound clear to you. We'll share the link to this documentary in the meeting minutes. So if anyone has to hop off or if the connection isn't that good online, you're welcome to watch it on your own time as well. And then once this is over, we'll, see if anyone has any thoughts, reactions, questions, and we can discuss those as a group, but we will get this started now. Let me unmute.
Do you have any further interactions with Ray? What is he doing?
Let's be tired.
Oh, he is retired. Because ironically, he took my job. Now I'm working with his cousin at Hertz.
One sec, they just said they can't hear the audio on Zoom, so let me. Think that I need to share the window instead of the screen. Bear with me one sec, folks.
70,000 tons. Intense vigilance and rigorous organization are essential at all levels for these behemoths to be completed in time. In one of the shipyard's many warehouses, workers are building a section of the ship called a block. A special system is used to coordinate the production of the 9 ships, similar to a giant Lego. The ships are assembled in the dry docks in huge basins. One by one, the blocks are delivered and welded together, an extremely efficient construction method. Each block has a precise function and specific place in the overall construction of the ship. To produce these giant vessels without wasting time, the construction plan was broken down into thousands of independent blocks, like an assembly line. And to save even more time, everything's already installed. Piping, fittings, ready to be connected. These huge parts are brought to the center of the shipyard near the dry docks, where they're mounted on the part of the ship already built. Like a skeleton, every single part of the ship becomes visible.
Donc là, on a un bloc qui n'a pas encore été assemblé, donc ça nous permet de voir une coupe de la structure de la coque du navire. Donc ça, c'est l'épaisseur de la coque du navire.
These floating giants have a very thin but extremely strong outer wall. A complex puzzle with countless pieces.
Il nous faut environ 399 blocs pour assembler la coque. Chaque bloc va peser entre 150 et 300 tonnes. Une fois prêts, les blocs vont être soudés entre eux.
All parts need to be assembled with surgical precision. Part of the tail, consisting of 5 blocks, slowly moves towards the basin like a spaceship from Star Wars. 790 tons, the weight of 2 high-speed trains, floats in the air. No problem for the massive port cranes, which can lift up to 600 tons. 2 cranes working together. The assembly of the massive parts has to be perfect. But how's it possible to build the ship without blocking access to the bottom of the ship? How can individual parts be protected from getting damaged on the ground? The trick? Small, incredibly stable support beams, known in technical jargon as pawls. The pawls are placed on the bottom of the basin so the ship can be placed on top. A pawl consists of a concrete block with a metal structure attached on top. Each one can carry 200 tons without damaging the hull. Together, the pawls support the weight of the completed ship, nearly 70,000 tons. Everything's ready for the next mega ship to be assembled. In the beginning, there was sheet metal, 12,661 steel sheets. They're the raw material for the structure of container ships. Just like cells in the human body, they're delivered by sea, by the hundreds. The structure of the ship is made of these sheets, mainly steel, a material that can be used over and over again.
La beauté d'un navire, c'est qu'il est à 99,9% recyclable.
When the ship's dismantled in 30 or 40 years, almost all the parts can be recycled. This sheet metal field is located near the warehouse. Thousands of plates are waiting to be cut to size.
A Chewy pharmacy order is on the way for Gouda. Meds verified by Chewy's license.
Unmute for the folks online. We'll just turn the audio back on once the ad is over. I didn't realize that giant ships like these were so recyclable. That was very interesting.
Yeah,
The steel can be used over and over again.
I'd like to know definitely what they would consider the purpose point for it, but.
Yeah.
Yeah.
Yeah, very interesting.
The US ports can handle it, those ships with that?
I think that a couple of them can, so it would probably be just Los Angeles, Houston, and New York, New Jersey. Those are the only ones that I know of that can handle this size. I'm assuming they can handle this size of ship because those are some of the largest ports in the world, and so if those ones can't handle it, I would imagine that these would be too big to be used at most ports to be useful.
But why are increasingly larger container ships still being built? Reducing the cost of transportation isn't the only reason. Environmental factors also play a vital role. If 23,000 containers can be transported by one ship, the life cycle assessment of each of these containers improves.
Nous avons juste un moteur, certes, beaucoup plus imposant que celui d'un moteur de camion, mais qui, en soi, va polluer moins que les 23 000 camions qui vont transporter leurs conteneurs d'un bout à l'autre.
So sea transport is comparatively more environmentally friendly than air or road transport. Propelling increasingly large ships while being environmentally friendly is a real challenge. One of the main challenges of the early 21st century is to keep the carbon footprint as low as possible. So a revolutionary propulsion system was developed for the 9 ships. Unlike older generations of comparably larger container ships, it no longer operates using oil, but rather it's powered by liquefied natural gas. Some smaller ships are already powered this way, but the use of this fuel in a container ship with 23,000 units, that's innovation.
C'est une grande première mondiale. C'est la première fois qu'on va construire un moteur de cette taille et de cette puissance qui va fonctionner au gaz.
The choice of this fuel represents an important advantage, a drastic reduction in greenhouse gas emissions. A trip pollutes the environment far less than using oil. Liquefied natural gas is certainly progress in the race to reduce the carbon footprint of cargo ships.
Le gaz naturel liquéfié permet de réduire de 20% les émissions de CO2, de 85% les émissions d'oxyde d'azote, de 99% des oxydes de soufre et les particules.
A considerable improvement. But the engineers also face a second problem, a ship's independence. The majority of routes run between Asia and Europe, so fuel supply is an important core issue. The fewer stops a ship has to make along the way, the lower cost and travel time. Container ships powered by liquefied natural gas have to cover enormous distances without any intermediate refueling. Storing such an enormous amount of liquefied natural gas on board presents a complex challenge. The French company GTT, world market leader for liquefied natural gas tanks, developed a customized solution for this project. It's the largest tank ever built. 51 meters long, 27 meters wide, the tank measures 18,000 cubic meters, as much as 6 Olympic swimming pools. The liquid gas offers a huge advantage and solves a familiar problem.
Le volume occupé par le gaz, une fois transformé à l'état liquide, est 600 fois inférieur au volume qu'il occupe à l'état gazeux. Donc vous concentrez un volume de gaz tout à fait considérable à l'état liquide.
The requirements are intimidating. To ensure the gas remains liquid, it needs to be stored between minus 161 and minus 163 degrees Celsius. So the tank has to not only withstand the temperature, but also be able to maintain it. To do this, all the inner walls are covered by several layers of insulation, which is more than 27 centimeters thick. So the tank is similar to a casket, dense and durable, like a giant freezer in the center of the ship. After a 6-month phase of block assembly, a new stage begins, installing the tank. To do this, a block must be completely isolated, a lengthy and critical stage that requires meticulous precision, and which can last up to 9 months. How can the natural gas be perfectly insulated at minus 161 degrees, and in a tank exposed to wind and weather on the high seas? To accomplish this, 27 centimeter thick sheets of polyurethane are used. They protect the outer walls from the extreme cold. The panels are glued to the walls of the tank and then fastened. That's why the tank is divided into several levels, so workers can cover the entire surface of the huge hull, a work phase that takes 7 weeks. The first layer of insulation is ready, but is it absolutely airtight too? Even though it's always a race against time on the construction site, the crews still have to make sure everything's working properly and check every single seam. The work's divided into inspection zones. A leak was found here. In such cases, technicians use an efficient method, which is surprisingly simple.
Water.
The affected section is covered with soapy water. Then this plexiglass box is used.
Let's see here.
A vacuum is created inside with a pump. If air bubbles escape through the inner wall, it proves the seam isn't completely airtight. Then you need to glue that spot again, of course in a timely manner. It's important not to waste a minute. The procedure needs to be repeated on the lower levels. The countdown continues. After 16 weeks, the first stage of installing the tank is complete. A second, much longer stage is about to begin. The tank is the energy reservoir of the ship. From here, the liquefied natural gas is routed to the engine. The problem is, both the gas volume and the distance to be covered are extensive. Because of balancing, the engine is located at the other end of the ship. So a suction mechanism needs to be built into the tank. Here it comes. Its weight, 25 tons. Its task, to pump the gas to the engine. Its name, the gas mast.
Le mât gaz va supporter un élément fondamental du fonctionnement du navire, c'est-à-dire les pompes qui vont alimenter la chaîne gaz, lequel gaz va alimenter le moteur.
The engineers had to design a mast that is virtually indestructible because it needs to withstand extreme conditions in the tank.
Dans cette cuve, on a des mouvements de gaz liquéfié à moins 161 degrés.
The lower the tank gets, the more waves of liquid gas beat against the mast located in the center of the tank.
Il va falloir que ça tienne pendant extrêmement longtemps. Donc c'est du très solide. C'est quelque chose de très impressionnant à voir.
The mast needs to withstand freezing cold and enormous pressure without moving even a millimeter, and do that for several years. Work continues at the enormous Shanghai shipyard. A tank obtained its first layer of insulation on one of the container ships. Now a second one can be attached, but the gas mask needs to be installed before that. It's lowered into the tank from the top. The mast is 6 meters wide, and the opening through which it's lowered is barely larger. The mast is lowered centimeter by centimeter. Around 15 workers are involved in this delicate operation. The metal monster floats in the air. Finally, the mast is now securely attached. There are 4 pumps at the lower end, just a few centimeters above the bottom of the tank. They pump every drop of the liquid gas.
Quand on voit ça, on se demande mais comment c'est possible? Comment ça va tenir? C'est suspendu au toit de la cuve et ça descend jusqu'en bas avec la pompe qui va pomper le liquide au plus près du plancher de la cuve.
A device that's proven its reliability. Now the tank's last layer of insulation is added, the so-called primary membrane, a 1.2 millimeter thick sheet metal. It's what gives the tanks their waffle-like surface structure. This membrane is ultra-thin and at the same time incredibly efficient. The intense cold of the liquefied gas causes the steel to warp, so it's crucial that the structure itself is flexible. The embossed membrane with its wavy edges offers the perfect solution.
Son génie, c'est la souplesse qu'elle a. Et cette souplesse, elle est produite par ces ondes. Ces ondes sur ces plaques d'acier inoxydable qui vont se contracter sans exercer d'effort sur les kilomètres de soudure qu'il y a dans la cuve.
Weld seams totaling over 6 kilometers run through the tank. They're extremely resistant. The same technology is also used in space travel. After 8 months of work, the tank is finally ready. A final inspection takes place before it's finally closed. Nothing, not the smallest speck of dust, is allowed to be left behind. The ship should be ready in 4 months. Today, 3 months after work began, is a special day for the engineers. They've come to the mainland because one of the core pieces of the project is being completed in these halls today. One of the most spectacular individual parts of the ship, the engine. With its 24 meters length, 18 meters height, and a weight of 2,000 tons, it generates an output of 85,000 horsepower. A genuine independent construction. Before the engine's mounted in the ship, it's tested to the extreme. The engine's pushed to its limits, to 110% of its capacity. This test is absolutely necessary to check the stability of the motor in extreme situations. Repairing this massive component on the open sea would be extremely complicated. And it was actually developed to simplify the work of mechanics. If there are any serious problems, mechanics can enter here to the center of the engine. But the tests went well. The engine passes with flying colors. It'll be installed in one of the 9 container ships in a few days.
Healthcare advocacy means being there for my patients to support them during.
Talk about high stress being the person who has to go inside the engine to repair it. It's malfunctioning out in the ocean.
It's the engine manufacturer.
That's a good question. It didn't say, but I don't know. You'd almost expect it to be a similar company as making the ship. Since it's
What's the price of building one?
Huh?
What's the price of building one?
Hopefully it'll say at the end, but I cannot imagine. I'm sure it's extremely expensive.
Is the company on the stock market?
That's a good question too. They're French, so what's the French stock market? Tom Phelan did share. He said that the port capacity for these ships is dictated by several factors, including channel depth, overhead draft limits, which are the bridges over the canal, and the handling capacity at the pier. So actually having cranes that can take them off. Tom, do you know if, like, by your estimate, do you think that some of those larger US ports would be able to handle these ships?
Yes, I think they would. Savannah is one in particular that comes to mind for the East Coast. What you find is that very often it's market driven, that sometimes it's just a matter of which ports are handling the sufficient volume from one carrier, from one vessel operator, to even justify bringing them here. Very often what you find is that if a carrier is making a single port call, say on the West Coast, they're running right to Los Angeles, you could justify using a ship that large. Very often on the East Coast, you run into issues because the ship will make multiple port calls, generally one in the north, basically north of Cape Hatteras, North Carolina, another one in the south. So you're going to have a ship that meets all the constraints of both ports where it makes the port call. So yeah, I haven't heard of any regular service by these, what they call like the 18,000 plus TEU ships here in the Port of New York and New Jersey.
Gotcha. Very interesting. Thanks for that insight, Tom.
Nine ships. That's 9 engines that have to be built in a very short amount of time. So they're manufactured just in time. The second engine's already being assembled just a few dozen meters away from the first engine. A critical step is about to be taken. The main piece will now be delivered, the crankshaft. The crankshaft is the axle that connects the engine to the propeller and powers it. Its weight, 220 and moves with the help of 12 pressure pistons.
Là, on est sur le cœur du navire. C'est ça qui va transmettre la puissance, c'est le muscle du navire.
First of all, the part is thoroughly oiled. The pressure pistons are connected later when the crankshaft's in place. This is genuine engineering. Almost 220 tons are waiting to be installed. This is done with the help of extraordinary cranes. So far, this is only half of the crankshaft. The 12 pressure pistons each have a diameter of 1 meter. That's 10 times more than a car. When running, they move 3.2 meters up and down. The engine's now mounted onto one of the ships. But before that, it has to be taken apart to be brought on board. And it's not that simple. No vehicle in the world could move this 2,000-ton massive part. That's why it's separated into 6 parts, transported individually by ship to the shipyard. This is the main part. It includes the crankshaft. The crankshaft is carefully lowered. With its weight of 350 tons, any unprotected contact with the ground would damage the metal. So it's carefully loaded onto beams. Even though the beams are temporary, they're still attached carefully. Now this highly sensitive piece of the engine is loaded onto a peculiar cart.
Cette pièce pèse 350 tonnes et pour la transporter de l'usine jusqu'à la grue qui va finalement la mettre sur la barge, on utilise un chariot. Ce chariot, dans notre langage, ça s'appelle une traîne.
To endure such a great weight, these transporters have up to 140 wheels. They weigh more than 10 semi-trucks. And they're controlled by remote control from a distance. Because safety's a top priority, the transporter only travels approximately 5 kilometers per hour. The ship's already waiting when the transporter reaches the barge. The engine's loaded as slowly as possible. Everything's ready to transport it to the shipyard. To get the container ships moving, which can weigh up to 300,000 tons when fully loaded, the propulsion system has a propeller with a very distinctive form. Their streamlined shape delivers increased performance.
Les pales sont étudiées de manière à ce que les filets d'eau le long de la coque et qui arrivent à l'hélice aient un passage optimum. Le nombre de pales est aussi étudié pour diminuer la consommation en combustible.
Back on the island, in the heart of the shipyard. This part was designed in Germany and made in China.
Voici l'hélice. Elle pèse 92 tonnes pour 10 mètres de diamètre. Et c'est cette unique hélice qui va permettre de propulser le navire à 21 nœuds, ce qui représente environ 40 km/h.
The propeller is connected with this huge round steel piece. The propeller shaft causes the rotation.
L'arbre porte-hélice va transmettre une puissance de 85 000 chevaux à l'hélice. Donc le but du test aujourd'hui, c'est de s'assurer que la surface de contact entre l'arbre et l'hélice soit parfait.
In other words, the 2 parts have to be 100% aligned. There can't be any discrepancy whatsoever. At full speed, the slightest inaccuracy would have irreparable consequences. A dye is used to perform the test, methylene blue. Now the 2 parts come together. The blue color shows exactly where the contact points are. A job of absolute precision, which can't be tampered with.
52.5. 5, 2.
Okay, now 52, it's okay.
The propeller shaft is raised 1 piece at a time. The propeller and propeller shaft fit perfectly into each other.
Là, on a un résultat parfait, on a 100% de contact, donc c'est super.
The operation was a complete success. In the next step, the 2 parts are finally assembled on board the ship. Because the construction of each ship is progressing at different stages, the quality and cutting of the sheets must be constantly monitored. The metal's cut with a laser beam. Generating heat of approximately 18,000 degrees Celsius, it cuts the steel like butter. In total, more than 880 kilometers of metal sheets are required for 1 ship. That's the distance between Paris and Berlin. There aren't any high-tech robots here and very few automated processes. Everything's done with industrial machines and human hands. Every worker has a place. This is where the first parts of a new ship are taking shape. These plates can now be assembled together to form new blocks. Work at the shipyard is carried out in several stages: by design, expansion, and inspection.
And now I want to see this, if it's good.
It's now time to assemble the last block. It's already waiting a few meters from the basin. André supervises the operation. The block is slowly lifted up, hovers in the air for several minutes, then fits perfectly in its place in the bow of the ship. Now it just needs to be welded in place, and the ship will be completely finished. These ships are gigantic metal construction sets, but they're also extra-large patchwork rugs. The connecting seams stretch across the entire hull like scars.
Là, en fait, on a deux blocs qui ont été préassemblés. On voit bien le joint ici, qui n'a pas encore été soudé. Et donc tout cela est assemblé par soudure, et il faut 1248 km de soudure pour complètement assembler la coque du Jacques Saadé.
1,248 kilometers. That's the distance between Marseille and Manchester. Sparks are flying all over the shipyard. Thousands of sheets are welded at the same time. Once the ship's at sea, there can't be any structural weak points. Like a weak link in a chain, the slightest mistake at sea can mean disaster. That's why every weld is meticulously inspected and redone if necessary. The simultaneous construction of the 9 container ships continues. Now it's time to install the propeller. The installation on the lower part of the hull is a delicate matter. The propeller was cast in one piece in a specially made mold. With its 92 tons and 10 meters in diameter, it can't be transported by air. So it's transported to the shipyard by ship. The last meters of the journey are conducted by massive cranes, which carefully load the propeller into the basin. The first thing that has to be done is to prepare the propeller shaft. Meticulous wrapping protects them from contamination. Nothing should interfere with the installation of the propeller. Now the propeller is slowly moved forward. Then, meter by meter, lifted and aligned. But how do you attach a 92-ton propeller? How do you manage to keep these massive parts completely still? The answer? Oil pressure. The men don't help. The propeller simply moved into place by oil pressure, where it's finally attached. Now the oil's injected. It's filled through this huge nut, and the propeller is precisely attached to its axis. The oil pressure increases as the entire team watches carefully. It's under constant observation. Adjustments take place directly on the hull, the old-fashioned way. Once the propeller's attached, the oil is collected to be reused later. Now the screw can be uncovered.
You play by the rules. Then things happen. Prices.
So just a quick thought. So I know you were asking about like what engine manufacturer that might be for this one. I'm not sure on the specific, but I know that there's a group called HD Hyundai, which used to be called Hyundai's Heavy Industries. They're like the largest ship engine, or well, they're the largest shipping manufacturer in the world, but they happen to make engines as well. And I was also searching if this GTT group did, but it looks like GTT outsources to a group like Hyundai Heavy Industries for their engine units, and then builds the ship the rest. But or that the fuel tank is what they focus on. So.
It was interesting them saying that the engine is 350 tons. That's about 700,000 pounds. So that's about the weight of stuff that we have moving through our region.
Yeah.
Shows the impacts. Tom also shared some more interesting stuff about the ports in the chat. He said that it's worth noting that once these ships become common in the maritime shipping industry, they basically become the standard size for major container ports. And there's almost a forced expectation that the ports catch up with the growing vessel size and address the constraints that they have at their sites. And they shared an analogy saying it's kind of absurd in a way. Imagine if the trucking industry and their customers started moving everything in super load trucks, and then all the state DOTs and local municipalities had to expand and upgrade their infrastructure to accommodate that. It's interesting that it's being led by the ships first rather than the ports.
I was hoping it was Caterpillar building those engines.
Yeah, it's interesting. It's it's a little sad.
Have stock in it.
It's a little sad watching these and seeing how all this major manufacturing is going on outside of the US.
We couldn't do.
We've disinvested in our manufacturing so much that
Well, that one group is out of South Korea. So
right. Short ad break though. We'll get right back into it.
This time, however, directly on board the ship. This is the lid, the upper part, the last missing part of the engine. The ship has to be able to transport hundreds of tons of goods without anything slipping. The massive piece hovers over the ship at a height of more than 20 meters before it's lowered into the heart. Everything's already prepared. The crankshaft and pressure pistons are just waiting for the last part of the engine to be inserted.
Quand on procède à l'assemblage d'un moteur comme ça, c'est un petit peu comme de la précision sur un moteur de voiture de course ou sur un réacteur d'avion.
Now the parts just need to be attached to each other. The ocean's a particularly hostile environment where the hull is put to the test. The salt and friction erode the paint. It's possible that entire layers of paint peel off. This clearly slows down the ship. The ship needs to put more pressure on the engine to maintain its cruising speed.
À ce moment-là, ça crée des turbulences et on augmente la consommation. Les filets d'eau ne glissent plus.
Controlled fuel consumption is a core feature of container ships. So the painting of ships is extremely important. It's crucial that mussels or any other organism can't attach to the ship. Painting is carried out in several stages.
Il y a plusieurs couches, de manière à protéger l'acier de la corrosion, de manière à ce que le navire glisse le mieux possible dans l'eau. Il y a plein de choses techniques derrière la peinture, ce n'est pas que de la couleur.
On that area, they have to do it.
Before applying the last layer, it's crucial to make sure the previous layer is perfect. And that's never the case on the first try. You can always find a mistake somewhere. An engineer examines the outcome himself. To be able to perform a comprehensive inspection, he climbs onto the freight elevator. But an inspection like this can be dangerous.
Whoa, whoa, whoa. Go down, down.
At this altitude, the wind sways the gondola quite a bit. If the ship's side isn't perfectly smooth, the spot is leveled with a grinding machine and repainted.
So this is the remaining. Once they will cut, we will do repair one more time. Okay.
An enormous job that has to be carried out on each of the ships. The total area to be covered is around 950,000 square meters. That's the length of 135 soccer fields.
Il faut savoir que le total du poids de la peinture peut faire jusqu'à 1% du poids du navire.
The last layer of paint can now be applied. This will take 1 to 2 days. Nearly 1 million liters of paint are used for each ship. About 2/3 of that protects the part of the hull that's underwater. This extraordinary container ship will carry a significant amount of goods, the equivalent of nearly 1 billion cell phones. Whether on the bridge or further down in the cargo bays, everything's transported in standardized containers. 12 containers can be stacked on top of each other in the cargo bay. When one's full, it's closed with a so-called hatch cover. Then another 12 containers can be stacked on top from the outside. Absolutely everything is transported in these containers.
C'est tout transporté dans les conteneurs. On va transporter du bois, des minerais, des matières transformées, des téléphones, des déménagements des voitures.
Of course, the cargo also contains fresh products like fruits and vegetables. You need refrigerated containers for that. They're connected to the ship. The warehouse has to be permanently ventilated because it produces heat.
Donc là, je suis en train de regarder les bouches de ventilation. On peut mettre jusqu'à 2000 conteneurs réfrigérés dans les cales du navire, donc c'est très important d'avoir une très bonne ventilation pour pas que les cales surchauffent.
A cathedral of steel on a massive scale.
Ça représente 50 000 mètres cubes. La cale fait 31 mètres de haut pour 56 mètres de large. On peut charger jusqu'à 12 conteneurs les uns sur les autres et 22 conteneurs dans la largeur. Donc il y a 11 cales comme celle-ci.
But how can so many containers be loaded and unloaded? Next to these ships, a truck looks like an ant. Huge cranes are used to load the cargo into the ships. They're lined up on one side of the ship, and their arms are long enough to reach the other side. The containers loaded by the cranes are stacked using a rail system. So the container towers get higher, layer by layer in the storage facilities, and on the upper deck too. The system's functionality is tested beforehand using a very particular method.
26 and 32.
A so-called container dummy is used for this, a replica that has the same dimensions as the real containers. An engineer checks to see if there's a problem. The slightest twist or any other distortion of the rails is noted and corrected. The moorings in the ground are also inspected. The cargo shouldn't move at all while being transported. But everything seems to be under control. Today, the engineer of the shipyard has done his job. Whether in calm or stormy seas, nothing's allowed to move. The containers must be prevented from falling into the ocean. To prevent this from happening, they're attached to the ship's structure above the bridge and to each other. This is done with so-called twist locks. Nothing can happen using this system, no matter how high the waves, no matter how bad the storm. The place where everything on board comes together, the center, the brain, is the bridge. Matthew's looking at it today. This is where the ship is steered when out on the ocean. The command bridge is still under construction. Workers are now laying the last cables and connecting the navigation devices.
Il faut savoir qu'il y a plus de 750 km de câbles sur le Jacques Saadé et des milliers de connexions à vérifier.
In addition to all the high-tech gadgets, you'll also find a few very classic navigation aids.
On a ici la barre. Ce qui est fou à imaginer, c'est que cette toute petite barre va permettre de faire tourner le Jacques Saadé, et c'est 285 000 tonnes une fois chargé.
But how do you dock such a massive ship? How do you manage not to damage the ship's wall, which is only 1.5 centimeters thick? Two specific outposts are detached for this maneuver, one on the port side and one on starboard. They know all the necessary commands.
Donc là, tu as la console déportée, je l'ouvre. Lorsque je veux mettre le bateau à quai, ici, je viens à cette position ici et je regarde le quai en bas. Je vais utiliser le propulseur d'étrave qui est là. Quand je mets les commandes à droite, le navire va aller à droite. Je remets à zéro. Quand je mets les commandes à gauche, le navire va aller à gauche. C'est l'avant qui est dirigé par ce système. Avec cette petite manette, je commande un moteur de 85 000 chevaux qui est directement relié avec l'hélice.
A maneuver that requires a lot of sensitivity. It's executed at a speed of 0.4 kilometers per hour. The problem is, despite the low speed, you can never see the bow and stern of the 400-meter-long ship at the same time. To solve this problem, a system called Smart Eyes is used. It contains 8 cameras distributed around the ship, providing an unimpeded view of the entire length. This allows the container ship to be moved close to the dock wall without great risk. After a busy year and a half, the construction of the first container ship, the Jacques Saadé, is coming to an end. The other 8 ships will be completed over the next 8 months. For the first time, the Jacques Saadé goes out to sea. There's a 15-day test phase where all the equipment is tested under real conditions. The tests are controlled from the command bridge, where all the equipment's interconnected. But the equipment alone isn't enough. It's only an aid to navigation. A machine can never replace a human being. The experience of the team is what matters.
Le navire est l'un des navires les plus informatisés électroniques du monde. On a toutes les informations que l'on désire. Toutefois, commander un navire, c'est croiser les données et être sûr de ce qu'on lit sur les écrans.
Speed 24611, distance 7596. Okay, thanks.
Every electronic device is tested, the mechanics too. How will the brand new engine respond? Speed tests are performed.
3, 2, 1, start!
During the test today, the engine performs as it should. There's another test awaiting the ship tomorrow. When the engine's off, the ship should stop moving. Now comes one of the most symbolic pieces of equipment, the anchor, which of course is also inspected. Like the ship itself, the anchor is enormous. This is where the anchoring is rehearsed and the performance of the anchor winch is tested.
J'ai regardé l'ancre, elle est bien droite.
This is the name given to the mechanism which returns the anchor to the ship.
Donc nous avons mouillé l'ancre par plus de 100 mètres de fond. Et maintenant on vérifie les performances du gain d'eau. On vérifie que le moteur est capable de remonter le poids de la chaîne et le poids de l'ancre qui pèse plus de 27 tonnes.
And that doesn't even include the chain links. Each individual link weighs 300 kilos. The total chain weighs about 372 tons. That's more than the weight of 60 African elephants. After a few minutes, the anchor rises to the surface. The ship appears ready to sail the world's oceans. With the inauguration of the first ship, the French shipyard has won the race against time. 9 gigantic revolutionary container ships were built in record time on this huge shipyard. The French company's gamble has paid off. The first completed ships will soon be traveling their routes. The others will follow. The global flow of goods continues to increase. Today, 90% of freight is transported by sea. 100,000 cargo ships already navigate the seas, so improving their life cycle assessment is an important goal for our planet.
Le monde maritime, d'une manière générale, est en train de vivre une révolution très importante. Le défi environnemental du transport maritime, il est immense.
The liquefied natural gas improves the life cycle assessment of the ships to protect the ocean, air, and the ports. But what will transportation look like in 20 or 30 years? Engineers are already busy developing future-proof solutions. The challenges ahead are daunting. Ultimately, the goal has to be an end to CO2 emissions.
Aujourd'hui, on n'a pas la solution sur la table, technologiquement, mais on y travaille tous. C'est une quête, une opportunité fantastique. Libérons les idées, libérons les cerveaux pour trouver les solutions.
Of course, constructing container ships like these is an enormous financial, economic, and technological challenge. But that's not all. These ships are also a great human adventure. Together, these dedicated women and men have accomplished a great achievement. Together, they overcame that challenge. A genuine challenge, as if made for the 21st century.
Zoom up so we can all see. That was very, very interesting. I hope everyone enjoyed that. I thought it was
excellent.
Yeah, very, very interesting look into how these ships are made. Does anyone else have any last thoughts or things they wanted to share?
Curious, with 9 ships, if they were worried about market saturation.
Yeah.
And just trying to fill ships of that size.
Yeah, that's true.
I guess that'll be the next challenge.
Yeah, it's interesting how I was saying they're already looking at how to basically make things bigger, how to future-proof them. That's something we're seeing in our region with freight stuff, is that it's just getting bigger and bigger.
I'm surprised they didn't mention at least one of the elements of the next generation of ships, being potentially the use of wind power. I've seen some concepts for this actually going back to a modern sailing ship with at least partial wind power to help reduce the demand on the engines themselves.
Like actually having big sails on the ship.
Yeah, they look more like giant solar panels. Like it's a fixed sail. It's not like cloth sails.
Yeah.
It
Interesting.
looks almost like it's about as aerodynamic as a house, right? Just a big flatter curved surface that to at least assist it and reduce the need to consume fuel on a long an ocean voyage.
Yeah, that is really cool. I would not have even thought of that we're bringing back sailing.
Well, there's a reason why it existed in the first place, right?
Yeah, that's true.
Yeah, you took advantage of what nature offered.
Yeah. Cool. Well, thank you all for joining us for that. That was very interesting. Hope everyone enjoyed it, and we'll
That was
see
a
you.
fantastic presentation.
Thanks, Tom. We'll see you all for our November meeting. Keep an eye out for that agenda. Thank you very much.